Yo guys and gals, 2019, A2, Unit 4, Mechanics section, last question. It's your projectiles. They've also combined it with a bit of vectors as well. Thank you, WJC. Right, it's a tennis ball question. You've probably done something similar in class, so let's have a look at it. They give the initial velocity, so you can think of that as being U, of 30 in the horizontal and 1.4 going down in the vertical. The initial height above the ground is 2.4. The height of the net is 0.9. You'll need that later. And it hits the ground there after 4/7 of a second, right? The net is X meters horizontally away from where the ball is struck. Find the speed of the ball when it first hits the ground, okay? Giving your answer correct to 1 decimal place. Okay, so I've written down all the stuff I've just said. So we know what acceleration is, 9.8 gravity. We know what the vertical distance is, 2.4 from when he hits the ball to when it hits the ground. We know that the initial vertical is 1.4, and we know that the initial horizontal is 30, right? Notice I've kept A as positive 9.8 as it's in the same direction as the motion of the ball there, right? Because it's a minus 1.4, and T is 4/7. So I'm thinking, right, what suvat am I going to use here? Well, I'm going to use V squared equals U squared plus 2AS in the vertical direction. And then I'm going to square add root the two components to get the magnitude of velocity, which is, of course, the speed, right? So V squared in the vertical is U squared in the vertical plus 2AS. I know that the initial component in the vertical velocity was 1.4. They told me gravity is 9.8 and the distance it travelled was 2.4 meters. Chuck all that on a calculator. Excuse me. V squared is 49. Nice square number. The vertical component of velocity is 7. They've told us that the horizontal component of velocity is 30, so square add root to turn that into speed, and it's 30.8 meters per second. Right, nice. Next part of the question. Find a position vector of the ball after 2/5 of a second, and that time is when it passes the net. Once we've found that position vector, and we can sub in 2/5, we can then determine the horizontal distance away from the net, and then we can also calculate the vertical distance of the ball above the net, right? Because they've told us that the net is 0.9 meters high. Right, now this isn't that tricky, actually. So we're talking about distances, so let's use S equals UT plus a half AT squared. Don't forget, U was given to us in the question. The initial velocity was 30t in the I minus 1.4t in the J. A half of gravity is minus 9.8 t squared in the J. Right? Don't forget, there's only acceleration in the vertical plane. Tidy that up, get all the J's together, right? So I'm left with 30ti on the left. Tidy these up here, put them into brackets, minus 1.4t plus 4.9t squared in the J. So that is the position vector at time t. Right, that's the first bit done. They then want us to use the fact that at 2/5, it's t equals 2/5, it's above the net. So that allows us to work out this distance x, 30 times 2/5. The horizontal distance it has travelled comes out as 12 meters. Don't know if any of you play tennis, but that sounds about right. And then if we check 2/5 into the vertical component of distance, it comes out as 1.056 meters, right? And I think of that as being 105.6 centimeters. Take away the 90 centimeters that the net is above the ground, and that leaves you with 15.6 centimeters above the net, which is handy because they told us the answer was approximately 16. So the happiest of all days there. Last couple of marks. The ball clears the net by only 4 centimeters. Why? Why is it not 16? And that's obviously because of air resistance and spin on the ball, right? You could put that for 1 mark. Suggest a possible improvement to this model. Well, because there's a rate of change of velocity because of the air resistance, maybe we could create a differential equation for velocity, because obviously it changes over time. That's how you get the last mark. Right, well done for battling through it all. I hope you understood it. See you at the next one. Bye bye.